Hello students, welcome back to my channel. Today we will see the module 1 of data structures and algorithm. First chapter will be of introduction. We are using this textbook that is advanced data structures. Let us see one by one. In this module 1, we are having search trees and balanced search trees. Today we are discussing only one module, that is search trees. In the balanced search trees chapter, we are only having the topic up to top down rebalancing for red black trees. And let us start with the chapter 1. First one is search trees. Chapter 1 is search trees. In that we are having many topics that are two modules of search trees. 2.1 is two modules of search trees. Second, 2.2 is general properties of transformation. Third one is 2.3 is height of the search tree. 2.4 is basic find and insert and delete. That is already we discussed in our BE. Okay. 2.5 is returning from the leaf to the root. 2.6 is dealing with the non-unique keys. 2.7 is queries for keys in an interval. 2.8 is building optimal search trees. 2.9 is converting tree into lists. And 2.10 is removing a tree. Let us discuss these things one by one. In this, there are many topics which we have learnt in our BE. They are only new things which are added in this DSA. We are aware of the modules. We are aware of the search tree. We have already studied in our BE. The next chapter is balance search tree. This we will discuss afterwards. First, we will discuss to begin with the search tree. As you know, the which we have already studied about the search tree. In simple definition, if we can define it, search tree is a data structure using it computer science for efficiently locating specific keys. Okay, it is also allows insertion, deletion, and search operation. Let us see what they have mentioned in our textbook for our syllabus. Okay, in our syllabus they have mentioned search tree is a structure. As yeah, I have already said you, it is a data structure that stores object. The search tree will store the object. Each object is identified by a key value. The object is identified by key value in a tree structure. Okay, the key values of the object are from linearly ordered set. Two keys can be compared constant time. Two keys can be compared in a constant time. Okay, and these comparison are used to guide the access to the specific object by its a key. Next is the tree has a root. As we know, a tree must and should have the root. Without root there will be no tree. Where any search starts, search always start from the root. That we already know, and that contains each node some key values for comparison with the key query key. So no one can go to different next node depending on whether the key query is smaller or larger than the key into the node until one finds a node that contains the right key. Next, this type of the tree structure is fundamental to the most data structure. It follows many variation and it is also building block for the most of complex data structure. For this reason, we will discuss in it in great details. While we are discussing the search tree, they have given the reason because the data we are using is more complex, so we need to sort that complexity, so they have used the search tree. Next one is search tree are one of the method implement the abstract search tree called dictionary. A dictionary is a structure that store object identified by keys and supports the operational find, insert, and delete. A search tree usually supports at the least operation of direct dictionary, but there are also other ways to implement a dictionary, and there are application of the search tree that are not primarily dictionaries. Okay, These are the definition or explanation given about the search tree. Now we will see modules of search tree. As I said you, there are two modules of the search tree. One is leaf tree and another one is node tree. Okay, we'll see the module 1, that is leaf tree. In that, the search tree is a binary tree where each interior node is serves only for comparison. Okay, all actual objects are stored in the leaves of the tree. The tree's nodes contains key for the comparison and the leaves contains the objects associated with the that key. Okay. Next we will see the node trees. In this module, each node can be considered a ternary node with three possible outcomes. Travels left if the query key is smaller. Travels right if the query key is larger. If the query key is equal to the node, the key object contained in the node is written. These are the two modules of search tree. This was a simple explanation which I have explained you about two models of search tree. Okay, if we compare each node the query key with the key contained in a node and follow the left branch if the query key is smallest and the right branch if the query key is largest, then what happens if these two keys are equal? The two models of the search trees are as follows. Let us discuss the condition they have given in this search tree. They are asking for if two keys are equal. First one, if take a left branch if the query is smaller than a node key. Otherwise, take the right branch until you reach the left leaf of the tree. The key in the interior node of the tree are only for comparison. All the objects are in leaves. Take the left branch. Second one is take the left branch. Query if key is smaller than a node key. Take the right branch if the key is larger than the node key. And take the object contained in a node if they are equal. We are finding how if both are equal means what we have to do. They have simplified this. Next one is the minor points. They have number of consequences in these modules. They have mentioned here. Okay. In module 1, the underlying tree is a binary tree, where in the module 2, each tree node is really ternary node with a special middle neighbor. In module 1, each interior node has left and right subtree, where in the module 2 we have allow incomplete nodes where the left or right subtree might be missing, and only the comparison of object and the key are guaranteed to exit. Okay, let us see the conclusion of this. In module 1, traversing an interior node requires only one comparison, where in module 2 we need two comparison to check the possibilities. In there they are making a comparison between the module 1 and module 2. They are telling the module 1 is more easier than the module 2. They are choosing they are always choosing the module 1 for solving a tree. They have also given the theorem. Let us see what the theorem says. A tree of the height h and module 1 contains at most 2 raised to h objects. Okay, a tree of the height h. What is the h? H is the height of the tree, and the module 2 contains at most 2 h plus 1 minus 1 objects. Sorry, I will correct myself. Module 2 contains at most 2 raised to h plus 1 minus 1 objects. This is the theorem they have given. They have given here the small explanation about the theorem. And this is easily seen because the tree of the height h has a left and right subtree. Then in the module 1, keys are interior nodes, etc, etc, they have given. In this model, each key appears only once together with its objects they have given. These are the explanation. This is the explanation they have given in this textbook about the two models. You can read it by yourself. It is displayed on the screen, each and every. In that, they have also given the diagram of the tree. They have created one tree. How the module 1 and module 2 is balanced in the tree, we have seen in this picture. See, the left one is module 1, as you can see in this display. Here right side will be the module 2. These are containing the values and the objects, and also they have built according to the rules of the module 1 and module 2. In this diagram, you can easily differentiate between the module 1 and module 2, and this is also consist of following structure. These are the structure displayed on the screen. This is of module 1, a tree of module 1. Type def and all, you have already studied how to write the structure in the Python and all. This is the Python programming language they have mentioned. They only mention here the structure. We usually some have additional information will be discussed in chapter 3. This is the explanation about the trees only, how we will insert and delete and all. You can read from the display what they have mentioned.